All right, the next problem I was asked about was problem number 22. So let's look at this one. This is a subtraction problem. It says 5 over 6x cubed minus 6x over x squared minus 2x. So just like pretty much everything in this unit, if you start by factoring, that would be a great place to start to make sure it's fully factored. So I'm going to go ahead and rewrite this problem. 6x cubed cannot be factored, but the denominator over here of x squared minus 2x, I can pull out an x. And so I get this term of 6x cubed on the left-hand fraction and x times x minus 2 on the right-hand fraction. And we know to be able to add or subtract any fractions, we have to have a common denominator. And my goal would be to find the least common denominator so I don't have as much simplifying in the end. I do most of my work up front. So looking at this, there's several things I see. Remember that each factor needs to be completely represented in this problem. And so if I notice that I need a 6 because of this 6 right here, I'm going to put that in because there is no other 6. There's no other number multiplied in front, so I need that 6. I also need this x minus 2, and I'm going to leave a space and you'll see why in just a second. X minus 2 because there's no other x minus 2 and I need to have that. Now comes the tricky part. I have both an x cubed and an x. I don't need both. I don't need 6x to the 4th in there, which is what x cubed times x is. So I need something that x cubed goes into evenly and x goes into evenly. And that term is x cubed. Now remember, we've said that this entire denominator needs to be represented, and that is. But we've also said that this entire denominator of x times x minus 2 needs to be represented. Well, that's a little bit trickier to see in this instance. So before I visualize that, I'm going to rewrite x cubed as x squared times x. Does that say the same thing? Do you think? That says the same thing as 6x cubed? Yes, it does. And so now I can see that this 6x cubed is still right here. There's my denominator there. And then this one is x times x minus 2. So both of my denominators are represented. There's nothing extra that I have there. They're both part of it. Okay, so to add or subtract, I need to multiply each fraction by what's missing from the denominator. And what is missing from this first fraction is an x minus 2. So I'm going to multiply both top and bottom by x minus 2. And what's missing from the second fraction? Well, I have x times x minus 2, but we can see in this part that we broke down that we're still missing the 6x squared. So I have 6x over x times x minus 2 was already there, but I'm going to go ahead and multiply this by 6x squared over 6x squared because that's going to give me the denominator that I want. Okay, multiplying these, I am going to multiply these two together. So we get 5x minus 10 over 6x cubed times x minus 2. Notice I'm not distributing the bottom. Leave the denominator factored. Don't distribute it. And on my second fraction, when I multiply those, I end up with 36x cubed over, again, I'm not going to multiply other than to combine the 6x squared and the x to get 6x cubed times x minus 2, just so the denominators look the exact same. Now what I'm going to do is I am going to combine them because my denominators are the exact same. Now I can just combine the numerators and we get 5x minus 10 minus 36x cubed. And there's no like terms in those, so there's nothing I can combine. And my denominator is 6x cubed times x minus 2. And we're done. There's nothing else. This is not factorable. This is not something we know how to factor. And so therefore there's no factors, and this is my final answer. Almost. Because the directions on these problems said to state your excluded values. If your excluded values or your domain restrictions, whatever you want to call it. Now, oftentimes I would like to state my domain restrictions back in the beginning of the problem, but I got a little bit excited talking about the least common denominator and totally forgot. So we're going to go back to that, those domain restrictions up here, or go back to this factored form that's up here. If we look at the problem in its factored state, my domain restrictions, or my excluded values, are things that make the denominator 0. So domain restrictions or excluded values are things that make our denominator 0. And so things that make my denominator 0 would be 6x cubed equals 0, x equals 0, and x minus 2 equals 0. So we're kind of using the zero product property here. We're taking all of the factors and setting them equal to 0. Now, for this expression, if we solve 6x cubed equals 0, the only thing that's going to make that true, I mean, I could divide by 6, we still get 0. I could take the cube root, and the cube root of 0 is 0, so we get x equals 0. Well, I knew that would be the case because I already had an x equals 0 there. And if I solve this x minus 2, we get x equals positive 2, and those are my domain restrictions. And so for our problem, we would say that x cannot be 0, and x cannot be 2. And so this is the finished product of my problem. And there's number 22.